All right, welcome back to the Unit 8 notes. This is going to be the 9th video for Unit 8. Unit 8, of course, being aquatic and terrestrial pollution. This video for Section 9, solid waste disposal. Of course, in this beautiful little depiction, that's probably not the best way to dispose of your solid waste. Now, solid waste causes pollution, which can be garbage and sludge. One great case study that you've probably heard of is the Great Pacific Garbage Patch, where high amounts of pollution and solid waste is essentially traveling through the currents in the Pacific Ocean, creating these giant Pacific garbage patches. And we'll look at some of the pictures from those. So the Pacific Garbage Patch is essentially between Asia and North America. It's carried through the North Pacific Gyre, and this is where basically any of the solid waste that's getting into the ocean is actually just continuing to join up with the rest of the pollution. So some of the items that they've found in the Pacific Garbage Patch: cigarettes and cigarette filters, food wrappers, beverage bottles, plastic bags, plastic caps and lids, plastic cutlery, straws, beverage bottles, beverage cans, and just paper bags. And what's really important to understand is that all of these items will eventually break down. The problem is that they're breaking down in the ocean, where there are species that rely on that ecosystem. So these are some of the images that have been taken of all of the waste that is in some of these patches, so you can get a real good example or an understanding of just how disgusting it is out there. If you look in some of these images, you might see some items that you recognize and maybe some items that you don't recognize, but it's important for us to just kind of understand that the waste that we produce is going somewhere. These are all lighters, I think. And over time, they do eventually start to break down into microplastics. So just, an idea. They found a number of soccer balls in the patch. And they've actually shown that they have soccer balls from almost every major country that you can imagine that plays soccer in the water in the Pacific Ocean. So obviously it is a little bit of a problem, as stringy materials can capture some of these, causing even more of a, it's kind of like just going to continue to get bigger and bigger because it attracts more and more waste. So we can just see, there's a little bit of beauty in these pictures, the art behind it, but of course it's also a little bit of it's a little disgusting to think about all this waste. So some people have actually taken waste to create art. A 38-foot tall whale is found in Bruges, which is in Belgium, which is made of 10,000 pounds of plastic waste. You can see some of the creative projects that people have done with the waste. Obviously better than just throwing it into the ocean or into a landfill. So we'll talk about landfills. Landfills, when we're talking about landfills, we're going to be looking at leachate and gases. These are the two main pollution sources that we look at when we talk about a landfill. So a leachate is just contaminated water that essentially goes through the municipal solid waste and then ends up in the soil and waterways. And with the, we are in class going to create a miniature model of a landfill, and we will capture leachate to just kind of see how disgusting it is, and hopefully if you capture it correctly, you won't pollute your water source. So there's 5 phases in a landfill's life, just like in the demographic transition, right? And we're looking specifically in these 5 phases of production of methane. So you can see at the very beginning, high levels of nitrogen gas and oxygen gas. And then in the second phase, we start to see a decrease in the nitrogen and oxygen and an increase in hydrogen and especially carbon dioxide. Phase 3 is really defined by the highest levels of carbon dioxide and the lowest levels of nitrogen and oxygen. And you actually don't see those two come back until the very end. Phase 4 is the anaerobic or stable methane fermentation phase. This is where we have methane and carbon dioxide as the main phase, and then finally the maturation phase, where the methane and the carbon dioxide levels begin to drop and nitrogen and oxygen levels get back up to normal. So how does the methane become produced? Well, you can have the carbon dioxide bonding with hydrogen to create methane in water, and then you can also have that looks like acetic acid. Yeah, forming methane and carbon dioxide. So in a sanitary landfill, which is what we're actually going to create in our small model, they aim to contaminate the surrounding environment as little as possible. So in a good sanitary landfill, you're going to start with obviously the subsoil. That's what's going to fall on the very bottom. And then we have a layer of clay, sand, a synthetic liner, more sand, and then the garbage on top. Now they also use in the clay level, they use a plastic lining which helps prevent leaks, and then they use a pipe to prevent and collect the leachate from the bottom of the landfill, which then they can put into storage tanks and treat. So the goal here is that the leachate, instead of getting into the ground, into the soil and then the groundwater, they try to pump it out using these pipes. So the solid waste is compacted here. On top of the solid waste, after you've completely filled your landfill, you would then put another layer of clay, sand, and then topsoil, which then hopefully creates an area that you can actually safely, it doesn't cause as much of a problem. They also then put a pipe in which collects that methane gas, and then they can actually recover it, process it, and use it to generate electricity. So again, there's plastic or clay bottom liner. There's stormwater collection system, which you can't actually see on this diagram. The reason they do that is because obviously if the stormwater comes in and collects the leachate, it can run off, and so they have to have a collection system so that it can prevent that. There is leachate collection. They also create leachate monitoring wells around the landfill so that they can test the levels to make sure that it's not getting into the soil or the water below. And then the clay cap on top. And if you guys remember, the reason clay is used is because clay doesn't allow for much water to flow through it. It has a very low porosity and a very low permeability. The methane, again, collection system on top, because if you remember, it's producing a lot of methane, so why not collect that methane and use it in electricity? So just in case you've ever wondered, how long does it take for garbage to decompose? Well, train tickets will take about 2 weeks, and orange peels about 6 months. Your milk carton, if it's a paper milk carton, takes about 5 years. 10 cans can take up to 50 years. Batteries about 100 years. And plastic bottles can take 450 or more years to properly decompose. And so this is why we are trying to prevent the use of some of these products as we move into a more sustainable approach. So the rates depend, of course, on the composition of the trash and the conditions needed for microbial decomposition. So if there's not a good level of microbes in the soil, it's obviously going to slow that decomposition rate. Another solution to dealing with waste is incineration, where they burn the waste and actually reduce the volume and mass. Depending on where you're at, different countries use this to actually generate electricity or heat, which they call waste to energy. And then the ash that's left behind is non-organic material that does not combust. So then they have to treat it, obviously. So this is just a general diagram of how the incineration works, but you basically put the garbage in, you have airflow underneath in rotating grates to burn the waste. There is collection of ash in the bottom, there's a combustion chamber, and then they're able to then use that heat that is being formed to allow it to possibly generate electricity, and then there's a catalyzer that is used to prevent the pollution of those gases. So in Vermont, they've actually created some disposal bans. Here in Reno, actually, there are certain things that you are not allowed to dispose of just throwing into your trash. But in Vermont, for instance, you're not allowed to put a lot of these items into your trash. You have to dispose of them in a different way. So appliances, these are all true. This is all true actually in Nevada. You're not allowed to just throw paints and stains and varnishes into your trash. You definitely can't just put tires, oil, anything that has mercury added, they don't want you to put in the trash. Electronics you don't want to put in the trash. Certain types of batteries they don't want into the trash. And then appliances, because all of these have different toxic chemicals in them that cause for problems in the waste site. Now, we also do recycling here a little bit, but not a huge amount. It's not nearly as good as it could be, but in Vermont, this is something that was done effective July 1st of 2015. They've started to create recyclables where they can recycle plastics number 1 and 2, cardboard, aluminum, glass jars and bottles. And they're starting to recycle organic materials because, as you guys know, one of the biggest sources of our waste comes from organics. So they actually are saying, hey, let's compost this stuff. Any extra dangerous wastes, these are extremely hazardous. So they actually make sure that you go through a very, very specific method of disposal. But they would say anything on this flyer you don't want to put in your trash because you should be recycling or composting or disposing of in a more proper way. In 2016, the free response question was as follows: many landfills do not accept used tires. As a result, the tires are often dumped in poorly regulated piles. Describe one human health problem associated with piles of discarded tires. Now, discarded tires can actually be a habitat for mosquitoes and pests that then are disease vectors, so they actually help to transmit diseases. And the other is tires can actually catch fire and release air pollutants. If you've ever watched The Simpsons, they have the giant city tire fire. So because of this known fact of mosquitoes wanting to habitat to use tires as a habitat, they're starting to create mosquito traps from old tires, and they actually are proving to be somewhat more effective than standard traps. So in this example here, a simple mosquito trap fashioned from old tires can actually take in mosquito eggs. It's effective, it's cheap. And in a 10-month study in Guatemala, they collected and destroyed over 18,100 mosquito eggs per month. So they're actually using this to attract mosquitoes to lay their eggs, and then they, instead of just letting them sit and reproduce, they then destroy the eggs, which causes less mosquito problem in the area. Electronic waste is actually only 2% of the waste stream, but it's pretty big concern because of what's in it. So some of the toxic components that exist in your electronics include lead, arsenic, selenium, polybrominated flame retardants, antimony trioxide, which is also a flame retardant, cadmium, chromium, cobalt, and mercury. If you have nickel-cadmium batteries in all laptops and hand watches, there's another hazardous waste that can be found in electronics. So 70% of the toxic materials that are actually in landfills come from electronic waste, so it's not a good thing. So this was done, I want to say not too long ago, but this was the iPhone 5, and they actually took it apart to find out, its overall ranking of what it had inside of it concentration-wise to see how hazardous the iPhone 5 was. And obviously you can imagine if you go further and further, it's probably, like the iPhone 11 now, I'm sure isn't great, and that's not good for me because I have the iPhone 11. Oh no. But in the button, just from the button, they found bromine, chlorine, lead, and mercury. In the circuit board, they found bromine, chlorine, lead, and mercury. In the processor, very little bromine, but a lot of chlorine and a little the highest amount of mercury. No lead was detected though. And then just in the case, there's bromine, chlorine, lead, and mercury, all hazardous waste. The other problem, of course, comes from ocean dumping, which was prohibited in 1972 by the Ocean Dumping Act. But, of course, China, Indonesia, the Philippines, Vietnam, and Thailand dump more of the rest of the world combined. This, just because it's prohibited doesn't mean it doesn't happen, so it's important for us to understand that just dumping things into the ocean is not good. So here's some sad images of animals as that waste traps them. They can ingest it, and they can become entangled in the waste. So the new way that we want to think about waste is in a life cycle analysis, or a cradle to grave. If we think about all materials and energy used in the lifetime of the product, from the raw materials all the way to the final disposal, thinking about what does it take to make it, and also what does it take to get rid of it. So the resources that go in, the energy, the water, and the raw materials, the extraction and processing, the design, the manufacture, the distribution, the use, and the disposal, right? So from cradle to grave, thinking about the life cycle. So if we look at that life cycle, we're looking at, the inputs, so the materials extracted, the energy that goes into this process, the raw materials, just the acquisition of those raw materials, which can release carbon dioxide and reduce carbon sequestration in forests. The manufacturing process, of course, releases carbon dioxide. The use, there is recycling, but don't forget that in the process of recycling, that has to go back to be more manufactured, which means you're going to release more carbon dioxide. There are also some of the nice things about recycling, of course, and this is this last part here when we think about it. By recycling, we're using less fossil fuels, and we're increasing the amount of forest carbon sequestration. More energy goes in to make the waste management occur. Now, some waste can be composted, which will release, of course, carbon dioxide, but it can also store some of that carbon in the soil, so there's a positive there. If we look at the combustion of waste, remember we talked about incineration. Incineration does release nitrous oxide and carbon dioxide, but it does prevent a little bit of fossil fuel use because you can use that as an energy source. And then the last one, of course, is landfilling. Landfilling, don't forget, releases methane, which can be uncontrolled, flared. Now, if we are able to use that methane, if we're able to collect the methane and use it for energy, we can avoid more fossil fuel use. The other part of landfilling that, of course, is a pro of landfills is that you have carbon in a long-term storage in the landfill. So we're actually putting carbon into the ground and storing it over a longer period of time. So that is the end of our 9th video. I know it's a little bit of a doozy, but this unit, of course, is packed full of stuff. So our 10th video will be about waste reduction methods.